In this video, we're going to take a look at some different parameters for binomial distributions. Remember, parameters are these values that are going to describe populations. And so when we talk about parameters for a binomial distribution, we're thinking about a mean or variance or standard deviation that describes the population of all the things that could have happened for a particular distribution. So we can use methods from way back in 5.1 to calculate the mean for a binomial distribution. We could create a table, and with that table we could identify here are all the values, here are the probabilities, we can take our values, and then we could take the values times the probabilities and add those up, and that would give us the mean. That's a way that we can do that. It will absolutely 100% work. So those methods, those work no matter what distribution you have for discrete random variables. However, when we have a binomial distribution, there is a simpler process to find the mean, and that's to take the number of trials, n, times the probability of success on a single trial, right? And so if you have a 8-question multiple choice test, every answer has 4 possible answer choices, and only one of which is correct. If you just blindly guess on all of them, abacadabra, then the number that you expect to get correct is 8 times 1/4. So 1 out of 4 you expect to get right. And there are 8 questions, so you would expect to get 2 questions right. That would be your mean. The variance is NPQ, where, remember, Q, that is the probability of failure on one item, so it's 1 minus, on one trial, so it's 1 minus P. And the standard deviation is then the square root of NPQ. Perfect. So those are, when we observe that we have a binomial distribution, this is the way I would calculate the mean, variance, and standard deviation. It's much, much quicker. And there's some intuition at least behind the mean portion of that. So let's look at an example. A student forgot to study for a 10-question multiple choice quiz. Each problem has 3 answer choices, only one of which is correct. We want to find the mean, variance, and standard deviation. And we are going to consider passing 80% or better. So would it be unusual for the student to pass? So let's first find the mean, variance, and standard deviation. So is this a binomial distribution? Yes. So every question, each of the 10 questions, is a trial. So we know going in that there are going to be 10 questions. The probability of success on a single trial is 1 out of 3. There are 3 answer choices, only one of which is correct, so 1/3 is our probability of success. So the mean we can calculate is NP. So that probability of success, that probability is the same from trial to trial. It's equal for each of those trials. The trials are independent, so if you have success on one trial, it does not impact the probability of success on any subsequent trial. So calculating the mean, we have n times p, which in this case is 10 times 1/3, or 3.33. The variance here is going to be NPQ, which would be 10 times 1/3 times 2/3. So the 2/3 comes from the probability of getting a question wrong. That's 1 minus P, so it's 1 minus 1/3, or 2/3. So when we go through and we multiply that all out, we get 20/9, or 2.22 repeating. And then our standard deviation is the square root of NPQ. So square root of NPQ, that's the square root of 10 times 1/3 times 2/3. So we get something like 1.49. The units on these would be like questions or number of questions right, correct. So 3.33 correct. Down here, 1.49 correct. For variance, it would be square of those units, so it's the number correct. Square questions correct, which makes not a whole lot of sense, which is why we tend to use standard deviation instead. We then want to know, would it be unusual for the student to pass? And so unusual, we want to know, is that unusual? And so we're going to use that range rule of thumb. The range rule of thumb says we're going to take the mean plus 2 times the standard deviation. So our mean here is 3.33 plus 2 times 1.49. And when we do that, we get 5.31 as a mean. Sorry, 6.31. So 6.31 as our mean, or as this value. With this value, an 80% out of 10, 80% of 10 is 0.8 times 10, because that's what our passing value is. Oh, shoot. Yeah, so that's our passing value. So you would need to get 8 right to pass. 8 is more than 6.31. So it is unusual. You could also say, is 8 unusually high? If we want to talk about unusually high, we would find the probability of 8 or more. And so to do that, I would go to StatDisk. So here in StatDisk, I am going to choose Analysis, Probability Distribution, a Binomial Distribution. We're going to have 10 trials. Probability of getting any one question correct is 0.333333. We want to know what's the probability of getting at least 8 correct. When we evaluate that, probability of at least 8 correct, 8 or greater, is right here. So 0.0034 is probability of 8 or more. So since that 0.0034 is less than 0.05, 8 is unusually high. So, yes, it would be strange to pass this test if you're just guessing on all of them. All right, in our next video, we're going to look at Poisson probability distributions. We will talk to you there.